the Pittsburgh, Pennsylvania office, and I'm glad to be doing today's webinar on SOLIDWORKS Inspection. If you signed into the webinar, you or someone you know or someone in your organization is probably responsible for creating inspection documents. These may include first article inspection reports or similar reports as defined by AS 9102, PPAP or in-process inspection reports, or generating any kind of inspection reports or inspection documents within your organization. If you do that, or someone in your organization does that, my goal is to show you how SOLIDWORKS Inspection can make your life incredibly easier by automating your inspection process. I'm not much of a PowerPoint guy, so I'm just going to jump into the product information. And again, the topic in the air today is SOLIDWORKS Inspection. In the next 30 minutes or so, my goal is to introduce you to this tool and hopefully illustrate the value of introducing automation to your inspection process. So, in my experience, inspection in many different organizations consists of basically taking a paper drawing and then a Sharpie and ballooning out the drawing as required, and then having a companion document, either a first article inspection report or a homegrown inspection report. In a worst case scenario, this inspection report is a piece of paper. In a best case scenario, it may be in an Excel spreadsheet. But for all but the simplest drawings, creating this document package of a drawing with balloons and an inspection report with assigned lines is a very tedious process. It's a manual, tedious process. The tool that we're going to take a look at today, SOLIDWORKS Inspection, is there to help automate this tedious process and free up your resources to do other productive things. A little bit history about SOLIDWORKS Inspection. It is the brainchild of a man named Jeffrey Cope, who used to be an applications engineer for TriMech Solutions. In 2007, he struck out on his own and started his own company, Extensible CAD. Jeffrey had a big, wide background in inspection and quality, and he realized that there was no application out on the market to automate the inspection documentation process. So he came up with a product called Inspection Expert. There are various flavors of Inspection Expert, and he wrote Inspection Expert as a plugin to most of the major CAD systems. In fact, we're going to take a look at the plugin for SOLIDWORKS first here today. But let's fast forward to last summer. Last summer, Jeffrey sold his product, Inspection Expert, for SOLIDWORKS to SOLIDWORKS Corporation. And he also sold his product, Inspection Expert Standalone, to SOLIDWORKS Corporation as well. Part of the reason is that the integration of inspection with SOLIDWORKS is so tight that he had previously achieved gold partner status with SOLIDWORKS Corp. So let's start out at 80,000 feet as far as the software products that are involved with SOLIDWORKS Inspection. SOLIDWORKS Inspection is actually two software products. One of them is an add-in to SOLIDWORKS, and its function is to automatically balloon SOLIDWORKS drawings. And that's what we're going to take a look at first to introduce you to the scope of functionality within this software tool. But there's also another piece to SOLIDWORKS Inspection, and that's a standalone application. We don't always have SOLIDWORKS drawings available to us. Quite often we're sent TIFFs or PDFs from our customers or vendors, and the standalone SOLIDWORKS Inspection application can also automate or semi-automate the process of creating balloon drawings as well as appropriately formatted inspection sheets. So when you get SOLIDWORKS Inspection, you actually get both pieces of it. You get the right to run the plug-in to SOLIDWORKS and balloon out drawings within SOLIDWORKS, and alternately you can run the standalone application to create balloon drawings and inspection reports for PDF and TIFF files. Finally, in the standalone application, there's also a bundle level called Inspection Professional, which we'll talk about at the end of the presentation, that gives you additional capabilities of inputting actual measurement information and getting instant feedback. You can also input information that is taken out of your CMM. So SOLIDWORKS Inspection is the closest thing to an app that I've seen in the SOLIDWORKS umbrella of products. It does one thing really well. It balloons out your drawings and generates appropriate inspection reports. Here in SOLIDWORKS, we load in SOLIDWORKS Inspection through our add-ins. So if we go to our add-ins, you'll see in our list of available add-ins we have SOLIDWORKS Inspection, and it's currently added in to the user environment. And what do we get by adding that in? Well, not a whole lot. We get another tab in our left pane, our SOLIDWORKS Inspection tab. We get a toolbar, our SOLIDWORKS Inspection toolbar, with 12 buttons. And we also get a pull-down menu here under SOLIDWORKS Inspection. So there aren't a lot of controls here, but what it accomplishes quite well. Once we've added that in, we can use the controls available to us to basically start creating an inspection report. Start creating a scenario where the various characteristics that we would like to have ballooned out are established. And we kind of take a wizard type approach to it. Right here in the left pane of SOLIDWORKS, when I click on the Create Inspection Project command, what we get is a list of project settings. You can think of these as project templates. Inspection project templates allow us to specify and preserve different inspection regimes for different purposes. Think about different manufacturing processes for forged parts versus machined parts. The general tolerances for those kinds of various kinds of drawings are going to be different. Think about different acceptance quality limits for different customers. You may have an AQL level of 2.5 for one customer, or an AQL level of 5 for another customer. Finally, many customers have unique specific quality regimes, and you can preserve any of the settings we're about to set up here as a project template. So you can parse it out any way you wish for different inspection regimes. I have a template already established here, and I'm going to be using my default template. I'll show you in a moment how you can create your own template as well, and we'll simply accept that. Now, the first sheet in this wizard is to create an inspection project. We're going to give values to these various items, such as the part number and the part name, and the document revision, and the document number. And this information is going to propagate over to our Excel-based inspection report. You don't have to type items in here, but you certainly can if you wish. Because this is an embedded application, we can actually extract information from our SOLIDWORKS custom properties. So if I wish, for the part number, I can grab the custom property value of part number from the drawing, from the model file, or any configuration-specific values that exist in the model file. So I want this part number to propagate from the custom properties from the drawing. The part name, well, I'll use my description here, the sensor housing. The part revision, well, it's Rev 1. And again, we're just extracting these seamlessly from the custom properties available to us from our SOLIDWORKS documents. We also have a document number associated with a custom property from the model. And we can even type things in as we wish. There's a drop-down here that allows us to specify a vendor. Now, if you don't have vendors in your environment or in your workflow, you can use this drop-down for anything you wish. This could be customers. These could be machine names. As you'll see, you have an opportunity to create a column or a cell in your inspection report that will extract the value of the vendor from the values that we've put in this sheet here. And we'll put in a job number of 1, 2, 3, 4, 5. And again, in a short while, you'll see how these values propagate over to our inspection sheet. The verbiage we use to describe an item that's to be inspected is a characteristic. And we can specify what the starting number is for our characteristic balloons, how it's going to sort the balloons in our drawing, whether clockwise or counterclockwise, and finally what the default classification to be assigned to each extracted characteristic. And again, you would use a a majority type rule here is, the classification that's most prevalent in this particular document should be the one that you specify here. That will be the classification applied to all the characteristics, and then you can deviate from the outliers as required. So we'll say these are all major classifications. There's numerous statistical techniques for establishing the proper number of samples for any quality regime. AQL is an acronym that's thrown about a lot, acceptable quality limit. And as a statistical technique, SOLIDWORKS Inspection is aware of this. We can specify a lot size and the inspection level and what type of inspection is to be conducted, tight, normal, or reduced. Again, if you have a sketchy vendor, you might want a tightened inspection sampling regime. Finally, you can specify the acceptable quality level, and we'll see how this propagates over here in a bit. As a wizard, we're going to click on the next button in our property manager to take us to the next sheet. So once we've established the overarching parameters of this inspection project, we need to tell inspection what kind of values to look at in the drawing. And we get to extract dimensions, notes, geometric tolerancing symbols, etc. And we have even further search criteria here as far as the dimensions go. For example, if I wanted to extract or balloon only inspection dimensions, I could do that. If I wish to include reference or basic dimensions, I can do that as well. We can accommodate secondary units, overridden values, etc. There's a search routine that will also extract and apply balloons to various notes within our drawing sheet or our sheet format. And then it will even explode those items into multiple lines if we wanted to. We can grab geometric tolerancing symbols, hole callouts, weld symbols, and surface finishes. The overarching philosophy when you're specifying what you wish SOLIDWORKS Inspection to extract from this drawing is you want to do it in a wholesale manner. You want to grab more stuff than you really need, and then you just turn off or exclude the items that really aren't important to you. This overarching wholesale approach really streamlines the process. I'm going to move on to the next sheet in our wizard, and now I get to specify the tolerance settings. For any given dimension that is ballooned out, I get to specify precision values here for dimensions that are not explicitly tolerances. This is comparable to the block tolerances. If you take a look here in my title block, you see that I have general block tolerances for any dimensions that do not have explicit tolerances. And this is where I get an opportunity to mimic or specify the values in my block tolerances. So for example, in this particular case, I want a plus or minus 20 thou tolerance for any 2-place decimals, so it complies. Our 3-place decimals at plus or minus 5 thou are just fine. We can also specify angular tolerances here, and we'll keep that at a similar values as required. We're not limited by using precision values. Again, remember, these values are going to be applied as the tolerances for dimensions that do not have explicit tolerances. Another approach we could take is we could say that we want to apply our tolerance, our block tolerance settings by a range. If a value, dimension value is between 1 and 3 inches, it might be plus or minus 15 thou. But if it's 3 to 12 inches, it might be plus or minus 30 thou. So you can also set up a tolerance regime, a tolerance settings like that as well. And finally, we can access the document defaults in the SOLIDWORKS unit settings and simply use those. I'm going to get back to a full view here. After you've specified your general block tolerance settings, you notice that the next button is grayed out, and this is where we get to click on the OK button. And again, I hope the delay that occurs with online webinars really doesn't affect the dramatic results that we get. If I was doing this live, I usually say, if you blink, you're going to miss it, because look how fast SOLIDWORKS Inspection balloons out our drawing. Done. It's that fast. So based on the criteria that I specified here, we now have these various balloons that are associated with various dimensions here within our drawing. To observe the characteristics or the nuances of any given item that we wish to inspect, all you need to do is click on the dimension. Once we click on this dimension, we see that this is associated with characteristic item number 6. Its nominal value is 0.750, and based on our block tolerances, it calculates the upper and the lower limit. We get additional information here about the configuration that the drawing view represents, our acceptance quality limit, and the number of samples we have to run to achieve that acceptable quality limit. We also have the opportunity to override these values. While these are the calculated values based on our block tolerances, we can key in or put any values in here we wish based on customer requirements, user experience, etc. Now, any dimensions that have explicit tolerances, such as this 1.901 or the 1.781, when I select one of those, you'll notice it's grabbing the plus and minus tolerance excuse me, from the explicit tolerance, and it's calculating the upper and lower limits, again, as required. It is robust enough to realize that a dimension like this, with an R in front of it, is a radial dimension. And again, it's going to look at the value and calculate the upper and lower limits. Some of the other things we can do in here is we can say that the inspection operation or method involved here might be, let's pick one as far as our inspection method. We might use radius gauges. To inspect that particular dimension. We'll move around a bit here. And for a dimension like the 1.113, maybe for something like this, item number 34, we'll tell it that we want to use an inspection technique of digital calipers. And we can even put a comment in here. We'll take roughness into account, or any other note that you'd like associated with this guy. Again, for any given dimension, such as this 800 thou dimension, we can tell it that classification for this dimension might be a critical dimension, and then it will be noted as such in our report. There's another aspect, and that is key dimensions. So if this 1.368 is a key dimension, characteristic number 19, when I tell the software this is a key dimension, we get the opportunity to specify a different balloon type to basically flag for us that particular different key dimension there. And it didn't appear to be working for me right now. Let me go into my balloons here real quick and make sure that setup is appropriate. We'll try that one more time. I'll say that's a key dimension. There we go. We got our flag there. If SOLIDWORKS Inspection has grabbed dimensions that we're really not interested in measuring, or maybe difficult to measure in a particular view, you can always select that particular item. You notice this 1.040 is item number 5, but I can tell the software to ignore that particular one, and notice it renumbers all of the dimensions, omitting that particular item. Again, how long would this take with a Sharpie while you're also trying to correlate these values in a paper or Excel-based inspection report? It might take pretty long, particularly in a complex drawing. So dimensioning or ballooning this out is only half of the challenge. The other half of the challenge is the accompanying inspection report. Well, we can create an appropriate inspection report that is appropriately correlated to the balloon characteristics on this drawing with the push of a button. You notice here that we have the opportunity to export this information to Excel, and we use Excel templates to do the magic that we're going to see here that's going to generate our custom inspection report. You get to use any number of different Excel spreadsheets that may have any different format, again, that your customer requires, or your first article inspection report standard format or a PPAP format. I have a general inspection report format that I'd like to use here to illustrate what we can do. When I hit the OK button, again, don't blink, because you will miss the fact that it only took a couple seconds for this Excel spreadsheet to be generated for us. Now you can see in this spreadsheet, each of the item numbers correlate to a balloon. So if I go in here and I say, hey, this dimension 1.130 correlates to characteristic number 10, well, if I go to number 10 here, there's my 1.130. It's using the block tolerance of plus or minus 5 thou, and I'm ready to print this guy out along with the ballooned drawing and send it off to my QA/QC department. I also want you to notice that we can access the information that was input so that that 30 thou radius is to be measured using radius gauges. And you notice even in our comment section here for that characteristic number 33, we told it to use digital calipers, and we even get our note in there to take the roughness into account. If we make any changes to our model, if we add or remove any dimensions, we can recalculate our balloons, and then again with a single push of a button, generate our inspection report. This is the scope of functionality with the integrated SOLIDWORKS Inspection as part of the add-in. Are there any questions? We can do a quick pause here and see if there's any questions from our audience. Alrighty then, let's move on. So the second half, or the other part of SOLIDWORKS Inspection that you get when you acquire this tool, is the inspection tool that will allow you to do similar functions here with PDFs or TIFF files. Oh, by the way, notice that this SOLIDWORKS drawing, all ballooned out, we can export it to a PDF in a single click here. And now in my folder in question, there's our PDF file, complete with all of the balloons as expected. So now this PDF and the accompanying inspection report become part of your inspection regime. But again, that's only half of what we can do with SOLIDWORKS Inspection. Let's take a look at the functionality we get when we wish to inspect to a customer's drawing, a PDF or a TIFF file. So I'm just going to exit out of SOLIDWORKS altogether here and launch the other application that you get with your SOLIDWORKS Inspection license. And that's this standalone application. We'll give that a second to launch. Excuse me. Now, if the overarching philosophy with the integrated SOLIDWORKS Inspection is that you take a wholesale approach and you remove the items that you don't want, the overarching philosophy with the standalone application is kind of opposite. Because TIFF files and PDFs don't have any real intelligence to the text that appears in them, this standalone application makes heavy use of optical character recognition. And you're going to see in a second here that we get the opportunity to window around various dimension values that show up in the PDF, and then using OCR, optical character recognition, SOLIDWORKS Inspection will extract out the nominal value in addition to any explicit tolerances that exist. The extraction characteristics or the project characteristics are somewhat the same as what we saw before. So let's just get into it so you can observe the similarities and the differences. Again, when I start a new project in the standalone application, I can use a project template. And again, these project templates allow you to preserve different inspection regimes for different purposes. I'll use this AS9102 template, simply accept that, and the next thing that happens is inspection asks me to pick an image file, a PDF or a TIFF file. So I'll just navigate to the appropriate location. Notice the file types available to us are PDFs, TIFFs, and TIFF files. Those are the three file types that this standalone application can work with. And I'm opening a multi-sheet PDF file just to illustrate that even this standalone routine can navigate multiple sheets. And of course, the SOLIDWORKS integrated tool can navigate multiple sheets as well. So in this particular drawing, you can think of this as a process plan. There's different processes that occur for taking a billet and sawing it into blanks and then chamfering it, putting a coring operation in there. So the front sheet describes the various operations, and then the subsequent sheets show you the dimensions that we'd like to see at the end of each of these operations. So this is a process plan in the purest sense of the word. We're really not interested in inspecting any characteristics on the front sheet. Let me show you where we set up our options here in the standalone application. And we'll find this here under the options. And now what we can do is go to these project options, and here we have similar types of controls as to what the various tolerances are, what unit system we wish to use, the tolerances that are available to us for different degrees of precision. And I'm just going to kind of go off here and say with 1 decimal place, we'll say with 2 decimal places here, it'll have a 0.03 plus and minus. And again, you can change this as you wish. You can add different items as well. We also have controls in here that allow us to manipulate the sensitivity and the settings of the optical character recognition. We can define the size and values and colors associated with our balloons. We're going to see we get the opportunity to export a PDF of the balloon drawing, etc. Various other applications options available to us here as well. We can generate custom lists for various machining and inspection techniques. It's very configurable. Again, anything you set up in here can be saved as a project template, so you don't have to go through all these gyrations again and again. Well, let's fill out our project properties. Again, we're going to see these values propagate over to our inspection report. While obviously we don't have custom properties associated with the PDF, we do have optical character recognition available to us. So for the part name, you notice all I need to do is window around the text, and it did a pretty good job of using OCR. The part number in this case, I can window around here. And if it doesn't do a perfect job, you can always edit these values. Our part rev is C. The drawing name, and we'll say that it's ion drive nozzle. Again, you can type any of this stuff in as you wish. And you can also populate or specify any custom properties, any metadata that you'd like to have migrated over to the inspection report. When you're happy with the project properties, we'll accept that. And now we're in a mode where the software is just waiting for us to start selecting dimensions, start selecting items that we wish to be included in this inspection regime. It's not very difficult at all. All we need to do is tell it what kind of item we're about to specify. You window around it. We get a balloon in here. The OCR does its job. It recognizes the fact that it was a +5 minus 0 tolerance, calculates the upper and lower limit, recognizes from the diameter symbol that this is indeed a diametric dimension. We can move on to our next sheet. and zoom in on the appropriate dimensions in question here. Window around those. Yeah, notice it did a great job of recognizing the nominal value and then the tolerance values. Zoom out a tad, move on to the next sheet. I think you see the general idea here. We can have the OCR recognize GD and T symbols. Notice the drop down here, various radius symbols, etc. We can get very explicit in terms of the nature of these various kinds of items, these characteristics that we capture through the optical character recognition. We can also use the OCR and tell it explicitly that it's a note, a GD and T, a surface symbol, etc. So let me window around this guy. If it doesn't do a fantastic job of grabbing the nominal value and the tolerance, we have some extra controls up here. For example, I could window around just these guys and say those are our tolerance values. So we gave it a second chance to tell it what we're really interested in grabbing here. We can go on to the next sheet. Maybe grab this critical dimension here. And again, it grabbed a little too much, not a big deal. With the limited amount of editing work that I need to do here, I'm still light years ahead of using a Sharpie and typing items into an Excel spreadsheet one at a time, or even worse, filling it out with paper and pencil. In a moment here, you're going to see how we can generate an inspection report similar to what we saw in the integrated SOLIDWORKS application. But I do want to show you one little extra bit of functionality that the standalone application has. And that is if you opt to go with Inspection Professional, the professional bundle, what that does is it opens the door for you to actually key in any measurement inputs as you are working on this document. So you can do all of your work on the PC without even having to export it out to an Excel spreadsheet. You can do this all here and then export it out to an Excel spreadsheet. I want you to also notice that we can populate these values. So say, for example, I go to this particular characteristic back on the first sheet. And I get the opportunity here to key in a value. So if I say, hey, this measured out precisely at 20.01, notice we get some color coding going on here. That's well within our tolerance, and now we get that nice green appearance in the background. If we're going to do more than one inspection, and I say, hey, for this next one, maybe it was 20.025. Well, that's still good. How about one more? And I key in something that is probably marginal, 20.05. Well, now notice we get that yellow warning color. And finally, I can say if we go over a particular value, it's 20.055, and it'll be over or under. Well, now that particular cell, for that particular sample, for this row, for this particular characteristic, this was a fail. So we use classic traffic light logic here. You can also populate these cells using a digital calipers with a USB connection to your PC. Or finally, if you wish, there are numerous pieces of software associated with CMMs, including Faro arms and Romer arms and various other CMMs, where you can import the output files from your CMM and associate each of the measured characteristics and values with the characteristic items in our bill of characteristics. So it's the ability to key in values, to extract them with a digital calipers, or finally to import the information from the CMM output files. It's these three bits of functionality that distinguish SOLIDWORKS Inspection Professional from the mainstream product. Again, at the end of the day here, we want to export out a PDF of the balloon drawing, and we probably want to export out an Excel spreadsheet as well. And we can do it all simultaneously if we wish. So I'm going to export out this part with a balloon suffix, and that works great for me. And there we actually get to see that with the various balloons. And now we get to specify for our export to Excel which of the templates we wish to use. And we'll use this PPAP report. And when I export this guy out, it writes it out to the Excel spreadsheet. And we'll see how we did here. And it exported out the nominal values, gives us our specification and limits. This particular report didn't show me the values from the data input, so let me try that one more time, maybe in a different report here. Perhaps I did the PPAP. Let's try the process performance. There you go. So now you notice we get the same characteristic number, the value. Looks like I need to do a little formatting work here. The nominal value, the upper and lower limit, and for each of the items that I keyed numbers in, the traffic light logic of red, green, and yellow carries through, and we even get to do a little statistical magic within Excel, which shows us our standard deviation, the mean value, etc. Again, all important stuff for the statistical basis of the inspection regime. Well, folks, I've been going here for 40 minutes. I hope I've accomplished the stated goals, which was to introduce you all to SOLIDWORKS Inspection. We've done more than expose the tip of the iceberg here. We've dived deep into the functionality, but if there's any questions that are unanswered, anything you'd like to ask now, this is your opportunity. If you'd like a more conversational forum, don't hesitate to reach out to us. You can call your TriMech Solutions account manager. You're welcome to reach out to me as well. Let's go and see if there's any questions here. Dana, are you still with us?
Yes, I am.
Okay, I don't see any questions here.
Not as of yet. Maybe we'll wait a little bit to see if any comes. Yeah.
Or they're just wowed into silence by the waves of awesomeness.
I think that's probably what it is. Exactly. Okay. I totally agree with that.
So if there aren't any questions right now, we're going to conclude this webinar. Again, here's my contact information. If you want to reach out to me offline, you're more than welcome to. And I enjoy talking with you about SOLIDWORKS Inspection or any other SOLIDWORKS products. Again, this is John Landis, Applications Engineer with TriMech Solutions, concluding this webinar. Thank you for your attendance.
Thank you all, and have a great afternoon. Bye-bye.